Hello and welcome to our tutorial. So we're going to have a look at some of the quite kind of rudimentary and basic attributes of materials that we were looking at in class today, and also hopefully I don't know if I can squeeze into this tutorial some lighting and a little bit of rendering. So I'm not going to add in any objects, just going to start with the basic cube, and we can view that in wireframe, in solid, textured, or rendered. So we can turn on and off our overlay, so whether we want to see the background or not, and also we can toggle this here whether we want to see the geometry in the background or not. So let's turn back on our overlay, and we're going to go to textured mode just for now. Just keeping in mind we're using the Eevee render engine for this, so this will give us quite a quick preview of what's going on. So the default cube has a material on it, so if we go to shading here, it comes with this basic, so the principal shader. So we can change the base color, so we make it blue. We can change how the amount of specularity, so a lot of sort of a you think of chrome kind of gleaming in the light, so how much of that we're going to get. And we can also change the roughness of the surface, so how much light will reflect off the surface and how much will sort of break up on the surface. It makes quite a big difference to this setting here to metallic. So normally you would either be fully metallic or not metallic at all. So I don't think there's any materials that are semi-metallic. So if I set this to be metallic and then I turn down the roughness, you can see that now I have a mirror, so I'm 100% reflective, and then as I increase the roughness of the surface, the reflection gets slightly diffused, and what we're left with is sort of an impression of reflection as opposed to something closer to a mirror. But this is often quite useful. This is what you might see on the surface of a car, for example. So if I want to add more than one material to an object, that is very possible. So let's just go over here to the materials tab, and we'll just see that this material here, which is the base material, has the name material. So let's just call this blue. So if I want to add another material to this object, I can literally simply hit the plus symbol here, which will add not another material. So the first thing we'll have to add is another layer. So now I have a blank layer, and I'm going to hit new here, and I've got a new material, which is identical to the one that we had started with. So let's call this red, and let's change the color from blue to red. And as we can see, none of this cube is in any way red. So how do we assign red to some of this cube? Well, what we need to do is go into edit mode, and then I'll turn on face select here. I can select any face that I want, so we'll pick this one here. And then with my red material selected, I can hit assign. And now this has that red material, and we'll go over here and do the same, hit assign. Oh, so blue is selected, so nothing changed, so select the red layer and hit assign. So I can have many layers here. I'm not sure actually if there is a limit. I believe there used to be a limit of 16. I don't know if there is now, probably isn't. And they can be of varying complexity and difference. Like these two are quite similar, but you could have a whole tree of nodes here, making this quite a complex multi-textured image or multi-textured material on this one surface within a single object. So it's quite versatile. We don't have to have multiple objects to have multiple materials, and that's of great interest to us, because what we want to do is make a character that is one continuous mesh as opposed to lots of separate objects. And the reason we want that is because we want to print it on a 3D printer. So having the ability to have multiple materials on a single object is excellent. So you can see here that one is reflective and the other one isn't. But if I jump down here and I reduce the roughness here and then make this metallic, that this also will reflect the environment. And if you're wondering where the reflection comes from, that's just sort of a world setting. So I can go up here to shading, I can click on this and I can pick a different sort of world high dynamic range image to have as my sort of preview. So this isn't, if I look through the cube here and I press render, that's not what's rendered out, that's just a preview. So we'll close this for a second. So let's go to rendered mode and see what we have. So this is what we'll actually get, which is, you know, slightly less exciting than what we had before. Now the materials haven't changed, just the environment in which our cube is placed has changed. Now we can, in a later tutorial, we'll look at how to set up environmental so lighting from an environment, which is quite simple, but we're not doing that in this tutorial here. But what we do want to look at is setting up the background and setting up the lighting. So the first thing I'm going to do is, because a lot of lighting has shadows in it, so we're just going to add a ground plane. I'm just going to scale this up, and I'm going to give this ground plane a material. I'm just going to call it floor, and I'm not going to do anything to it. I'm just going to leave it there, and I'll go GZ -1, so it's underneath my cube. Now, by default, before we get onto lighting, the default cube has a material which we have renamed blue, but there's also a default background. So if we're in object mode here, but in the shader window it says object, which I think is slightly confusing. So object mode and object, but this is referring to, these are the nodes for each individual object that we select. So the camera, for example, doesn't have a material, so it has no nodes, but it's still an object. So I can pull down this menu here and I can go to world. Now you can see there is nothing here, so I need to go over to the world settings here. So this is my world, and I need to tell it to use nodes, so to use this window. And when I do that, here is the current setup that is being displayed here, which is basically, it's got a background color of gray, and that's got a strength or a brightness of 1. So if I reduce this to 0, we will have a background color that is basically black. Okay, so we'll have nothing in the background. Now we'll go back to object. So let's look through the camera and make sure we're in our rendered mode, and we'll press F12 for a quick render, and you can see that the background is completely black, and what we're reflecting, because these are highly reflective surfaces, is also black because there's nothing to reflect, which is kind of interesting. So let's go back to our object here and make it less reflective. We'll do the same with our blue color. Now let's press F12 again and see what it looks like. So now you can see we can have a better idea of the colors that are involved. So I can see my red and my blue. Now I still can't see this side, but that's to do with lighting. So the light is coming from over here, and we're casting a shadow. So we'll have a look at shadows and lighting in a moment. So the last thing that we want to be aware of is the render engine that we're using. So at the moment we're using the Eevee render engine, and that gives us a very quick and excellent preview of what we're going to get here in the viewport. But when we render out of Blender, we're going to not use Eevee, we're going to use Cycles. And this is actually what we're going to end up rendering. Now at the moment it's set up to use my CPU, so I'm going to tell it to use my GPU, and that'll just make things a little bit faster. And I haven't got the best GPU in the world, but it'll be definitely faster than my also not great CPU. Now the reason I've switched to Cycles is so we can actually see all of our shadows, and we can have a little play with some of those settings. So I'm just going to go to my outliner here, or my collections, and I'm going to open this so we can see all of the different components in here. Now I haven't labeled anything, but that's my original cube, that's the plane, and then this is my lamp. So let's go to the settings for the lamp. Now at the moment it's a point lamp, so there it is. And when I move it, it behaves kind of like a light bulb. You know, if you move a light bulb closer to something, it will make the object brighter. So proximity is very important in terms of the effect that the light will have on the scene. Now, I also have here use nodes, so I'm going to click use nodes, and now I have in my node editor a node for this light. So if I want to change the color of the light, I can change it here like you would if you were changing a material. So our use of the lights is very similar to our use of materials, and then I can set the strength of said light from the nodes as well. So we'll bring this back to white for now. Okay. Now, so there are quite a few different settings for us to explore. Now, when we were in class today, we had a different interface here, and it'll be interesting to see what they actually land on in the final release of Blender 2.8. So I'm not quite sure what build I'm in here. So it's Alpha 2, so the 7th of November I think it came out on, so there's a couple of, well, I don't know, what day do we now? We are the 29th, so you know, 2 weeks old, so this has changed I think since then. Some of the settings that we had for shadows seemed a little more straightforward than the ones that are here, which are similar to what was in Blender 2.79. So I might do another video on this in a little while, but for now we'll just look at what's here and how it works. So I can turn on and off cast shadows, and then I can change here the size of the lamp. Now the size of the lamp is going to dramatically affect the way the light or the lamp sort of casts a shadow. So literally the area from which the light is being emitted is getting larger, and consequently the shadow is getting sharper. So this is literally being emitted from a very, very small, like the tip of a torch. Whereas when I make this much bigger, as the kind of the widget here or the icon would suggest, that's like a lantern now that is the light is spread over a larger area or being emitted from a larger area, and consequently my shadow is going to get more blended and diffuse on the side, so it's going to be a soft shadow. So in this version of Blender, that's how we change whoops, that's not the profile of the shadow from being sharp or hard to soft. The number of bounces is actually is more relative to the quality of the shadow, and I don't know if we zoom in here if we can get a better idea of that, but maybe we won't see it in this preview. Okay, so this is how the point light works. So we can move our light around, and proximity is a kind of a key factor in how the light and the shadows work together. The sunlight is completely different. So this is a sun. I'm just going to reduce this to a strength of 1. So with a sunlight, the position of the light makes no difference to the scene. It's basically, it's treating the sun as if it was, like the sun in our own sky. So it's the distance it is away is sort of in terms of how we interact with the light is kind of irrelevant. All that matters is direction. So when I rotate the light, I can get a very different effect on the objects in the scene. So moving this light closer to the plane doesn't make this the angle of the light any shallower. The only thing that is effective for that is rotation. Okay, So as before, we can make the size larger and smaller, and you can see here it's quite a dramatic shift in effect that we get from our sunlight by changing the size of it, in terms of the area affected by the light. Okay. So there's three others. We have a spotlight, and that spotlight is actually working. It works off a different scale. So the point light and the spotlight, if they have a strength of 100, will give you a relatively modest amount of light. And as we saw, if you click into sun, 100 is a lot. So they just work off a slightly different scale. We've a couple of extra controls with the spotlight, so we can change the size of the cone cast, and we can also the edge of this light, we can make it quite theatrical or quite hard, and this kind of works in conjunction with the size of the the emitter. So if this is 0, we'll get and the blend is at 0, we'll get a very hard shadow. We can blend this on its own, or we can combine it with making the source of the spotlight bigger, and then we'll have a soft side and a soft shadow. Okay, so all of these combined are responsible for how things look basically when we're rendering our image. So I was going to press F12 and we'll get a render, which is slow, and we'll have a look at how to speed this up in a second. So at the moment our sampling, so we're going to have a look at rendering now. The number of samples is 128. So the number of samples is how many times Blender is going to work out what each pixel should be, or what color it should be. So the higher this number is, the higher the quality of the image. So if we look here, for example, at the amount of noise in this image, as we increase the sample rate, the amount of noise here will be reduced. So we'll have a much better quality image. However, as we increase that number, we also increase the render time. So if you put in 2000, for example, this 53 seconds would turn into maybe 53 minutes or more. So this image here, which is extraordinarily basic in terms of it's got 2 materials, or 3 if we count the one on the floor. We've got 1 light and some very simple shadows. Took nearly a minute to render. So let's see if we can change some settings to increase the render, or to decrease the render time, so to make it a bit more practical. So first things first, we're going to go to one of the big factors is to make sure we're on GPU compute, because if I'd been on CPU compute it would have been even slower. We can change the sampling rate, so I'm going to leave it at 128 for now so we can compare what we had, which was 53 seconds, with the next render. I'm going to go to performance here, and I'm going to look at tiles and the tile size. So when we rendered there were lots of little small panels being rendered. So we're going to change the size of these to 512. Now they should be to the power of 2, because that's what graphics cards like the best. So either 64, 64, 128, 128, 256, 256, etc. You can make them as big as you like. Actually, the bigger they are, probably the faster it will be. But if they're too big, you'll run out of RAM on your graphics card. So basically these are the size of the bytes that the graphics card is going to take out of your image. Now, talking of size, let's have a little look at the sort of basic setup of this image here. So this is set up to be HD, so this monitor here that we're looking at is a high definition monitor, so it's 1920 by 1080, so it's got about 2 million pixels on the screen, and we're only rendering out 1 frame, and it's at 100%. All that means is that's a full resolution. And if we save the file, it's going to save a PNG file or GBA, so it'll record the alpha channel if we want, and it's only got 8-bit color depth, so we're working on kind of 16 million colors. So if you're using CPU compute, these should be small numbers. So the CPU prefers lots of very small renders, as opposed to the GPU, which is normally in a single processor, which will render at large, prefers to render with larger square sizes. The next thing we can do to increase our render speed is this here. So this is basically, if you can imagine, when it's rendering, because it's kind of a ray tracer, so what it'll do is it'll try and work out the number of reflections or bounces the light will travel on its way from the camera through the scene. And now you can put in lots and lots of them. So, but in this scene here, we don't need 12. So if we would rarely need more than 3. You may find, if light has to reflect onto an object and pass through, say, a transparent surface and then onto another surface and maybe reflect off that. If you had a very complicated image, you might want to increase these. But that is, we probably won't see a quality difference in the image with these set to 3. Okay, so now let's render this and see if we've improved on 53 seconds for our render time. So we're still at the same sample rate, so we're still at 128, so we haven't changed the quality, and we could have saved the other image to compare it to this one. And we can see here, this is the time, so 53.1 seconds is the render time from the last render, and this is our current render time. So it looks like we'll shave off maybe 10 seconds. Ish. Okay, so 11 seconds we got. No, 10. So you can. There are other factors that can influence the render speed. So let's see if we can, just for curiosity, we'll say CPU compute, and we'll go down and change these back to 64. And we'll hit render and see how that works. Now you can see there's 8 of these, and that's because there's 8 processors or 8 cores in the CPU that I have. But we'll probably find that this render takes a bit longer. So what you're trying to do all the time is kind of optimize the render. If we're just doing a single frame and it takes 40 seconds or 50 seconds, then that's fine. Or if it's an hour or an hour and a half, if it's your own PC at home, you probably won't mind. If which we'll be doing later in the year, rendering out an animation that has 300 or 400 frames, the difference between 1 minute per frame and 2 minutes per frame is quite profound when you multiply it out over hundreds of frames. So we will spend more time on looking at more settings to try and optimize our renders. And try and speed them up. And there are other settings that we can play with or change. Like I said, one of the main ones is, which we haven't changed here, is the number of samples. So we'll try that after this, and then we'll end our tutorial on that. So you can see we're already way over using the CPU. I'll let it run out just to give you an idea. It's going to probably be 2 or 3, well, won't be 3 times, but it'll be a good deal longer than with the graphics card, which is a NVIDIA 760 2 gig graphics card, so it is old and not special. So we have so 1 or 2.5 times, or it took 2.5 times as long to do that. So let's flick back to our GPU and let's pick somewhere in the middle. So we'll do 256 and 256. And what we're going to change now will make a considerable difference is we're going to look, so we'll leave all of these settings the same, but in rendering here we'll look at the main setting, which is the number of samples, so under sampling. So I'm going to change this from 128 to 50 and hit F12. And what we will notice is, and you probably see it already, is there's a lot more noise. So we've lost a little bit of quality. And it's, I suppose, at the end of the day, subjective as to how much quality you want in the image. But this is definitely a much noisier image in the dark areas. You can see sort of fizz. But I've brought it from 43 seconds to 17. So if you were making an animation, like I said, with hundreds or maybe thousands of frames, you may want to sacrifice that bit of fizz in order to reduce your render time. Okay, so that's a very simple and quick overview. We haven't looked at any texturing in this tutorial. We'll come back and do that, and we'll do UV unwrapping. But what we have looked at is some very basic materials, putting multiple materials on a single object and assigning them, having a very, very brief look at some of the basic characteristics of the material, the use of lights and shadows, and then some very basic render settings so we can output a still image of what the camera is looking at. Okay, so we'll leave it there for now.